All right, so now we're going to talk about z-scores. So z-scores are used to measure how far away a data value is from the mean in terms of standard deviations for any data set that is roughly bell-shaped. So instead of just looking at how many places away from the mean we are, we're going to calculate a z-score to tell us how many standard deviations away we are. And this is going to be really helpful, as you'll see in the next video, if you're trying to compare values. So the equation to calculate a z-score is you're going to take the data value for the individual that you're looking at, x, minus mu, and remember mu stands for the mean, and then we divide by sigma. And notice right now mean and sigma were both the symbols that we used when we had population data. As of right now, when we're calculating z-scores, we're going to assume that we are looking at population means and standard deviations. Things get a little trickier when we start taking samples and we're trying to do those type of comparisons, so we're just going to make it easy for ourselves right now. So let's go ahead and just do a couple of z-score calculations. So IQ scores are bell-shaped with a mean of 100 and a standard deviation of 15. Calculate the z-scores for the IQ scores below. So if you have an IQ of 92, how many standard deviations away from the mean are you? So we have a mean of 100, we have a standard deviation of 15. So I'm going to calculate the z-score for an individual with an IQ of 92. So the data value of my individual is 92, minus my mean is 100, divided by my standard deviation of 15. Now when we do this, we want to put this top piece kind of in parentheses. It's not officially part of the formula. However, it does remind us that we need to do 92 minus 100 and hit enter first before we divide by 15. If you just type in 92 minus 100 divided by 15 in your calculator knows the correct order of operations. So it's going to divide and then subtract, and that is not what we want to do. We want to subtract, we want to find out how far away from the mean we are. Then we want to find out how many standard deviations that is by doing that division. So 92 minus 100 is negative 8. And then we divide that by 15. So we get negative 0.53. And you can typically round z-scores to 2 decimal places. Sometimes we'll use a 3rd decimal place, but that's not going to happen for a while. So for now, you can go ahead and just always round to 2. So now we're going to look at another IQ score, 124. So we're going to follow the same process. So the person, the data value, the individual I'm looking at is 124, minus, we have a mean of 100, and a standard deviation of 15, because we're still looking at the IQ scores. So 124 minus 100 is 24, divided by 15 gives us 1.6. So this is the calculation of the z-score. So now we're kind of going to look at what does this mean. So we're going to create a simple empirical rule chart for this information. So remember our empirical rule chart, we start with a bell curve. And I'm going to start by labeling the center, which would be my mean, but I'm going to label the center in terms of standard deviations. So the z-score of the mean is always 0. And then we have 1 standard deviation above the mean, 2 standard deviations above the mean, and 3 standard deviations above the mean. And then we have negative 1 standard deviations, so 1 below, 2 below, negative 2, and 3 below, negative 3. So when we were doing this with the empirical rule, we were actually figuring out what those values were in terms of the problem. But I just want to look at where these z-scores are going to fall. So my first z-score is negative 0.53. So negative 0.53 is somewhere between 0 and negative 1. And it's a little more than halfway towards negative 1. So because this is a negative z-score, I know that it's going to be below my mean. And if I look at the original values, 92 is less than 100. So I should be on the less than part of my mean, on the left-hand side. And then if I label my second value 1.6, so 1.6 is between 1 and 2. And it's a little more, again, a little more than halfway between 1 and 2. Maybe it's like right there. And now this is a positive z-score, so I know it needs to be on the right-hand side of the mean. And remember, the z-score for the mean is 0. And then it falls between 1 and 2. So this tells me that 92 is just over half a standard deviation below the mean. And 124 is a little over 1.5 standard deviations above the mean. It's 1.6 standard deviations above the mean. So this is what a z-score is. This is what it tells us. And this is kind of how we would label where they fall on a bell curve using kind of a general empirical rule guide